My name is Sal Salas, and this is my presentation for my internship experience of summer 2015. Some academic background. I went to the University of Houston to study mechanical engineering for 3 years before I came back and started working and going to school, here and there. I began working at a surveying company in 2008, and in 2013, I earned my SIT certificate. I'll be graduating this fall, and will be taking my RPLS exam soon after. So I switched surveying companies in 2014, and since then I've been working at LNV Incorporated. So a little bit about LNV. The initials stand for the last name of the three primary founders, uh, and they are a multidiscipline firm consisting of engineers, architects, construction, and the last couple years surveying. So just some brief history. When we made the transition, and when I say we, I had the tremendous opportunity to transition with my coworkers to start the L&V surveying department. Many of those individuals I had worked or still working with. Many of us had worked together for 6 plus years. So some quick facts about fun facts about LNV. They bleed maroon through and through. They are an A&M based company. The owners all went and graduated from A&M, started the company together. I would say 90% plus of the employees from engineers, HR, IT, surveying graduate from Texas A&M or A&M Corpus. The structural department at LNV actually worked hand in hand with the artists to erect and build the Momentum sculpture, which has now become an iconic figure at the Texas A&M Corpus Christi campus. Some work experience. When I started surveying, I started as a CAD tech slash field hand, and then a few years later, I became a team lead and was supervising my own team of CAD techs. I earned my SIT and then got promoted to CAD manager slash training manager. And then after the transition to LNV, I got promoted to project manager. So as a project manager, what do I do? Well, my job duties consist of basically managing survey projects from beginning to end. That includes client relationships, being that main point of contact, dealing with MSAs, which are master service agreements, contracts, insurances, um, maintaining relationships with clients. And that includes marketing, going to visit existing clients, potential clients, going to conventions, basically selling ourselves. I maintain the office and field standards and survey standards. Um, I manage the team leads as well as their CAD technicians. I'm part of the QA QC process. Anything that goes out the door, preliminary, revised, comes across my desk and the RPLS desk, and we basically quality assure whatever is going out the door. I deal with billing and accounting issues, anything from timesheets, time approval, invoicing, anything that kind of financial transaction in our department I have to deal with, um, as well as continuing education, constantly teaching employees, learning new techniques and technologies, and adapting with um, the industry. So the basic overview of workflow process that I go through, and I'll go in more detail when I explain some of the projects I did or worked on, is you'll get a client request in some form or another, and then most likely you're going to have to do some kind of courthouse research or online research nowadays. You'll take that research and you'll draw it up, create a working sketch, you'll do some field work, you'll bring that data back into the office, process it. Most likely, if you're doing a boundary, you'll do some boundary resolution in CAD, and then you'll create some kind of deliverable, most likely a plat that's going to get signed and sealed by an RPLS. So one project I worked on was an Alta survey, which is just a very expensive intensive boundary survey on a commercial property off navigation. So the client request came in. In this case, it was a title commitment, which the title insurance company will provide, and they explains the tracks that they're purchasing that need to get surveyed. They'll provide you with some research, and it also has exceptions from coverage, and these are usually right-of-ways, easements, pipelines that need to be located because they're not going to be covered by the insurance. Now, you always want to do your due diligence and do your own research, even if it's provided for you. and make sure that you're researching back to the parent tract and not just using the latest and greatest survey, because it's usually sometimes a lot it's not correct. There's some mistake that's been made. So making that chain of title, connecting it, is very important. And following that long road of history can often lead you back to some very old documents, such as this pipeline easement uh, written in 1893. So you'll take all that research and you'll draw it up. We use Carlson and AutoCAD software, which is makes drawing deeds very easy. And you basically make a bunch of puzzle pieces, and just like putting a puzzle together, you're going to create your working sketch. So in CAD, you will start placing your tracks around your subject track, because a boundary survey is going to require you to also survey the adjacent tracks. So once you've done that, you've now built your working sketch and can start preparing for the field. But you can't forget, you have to draw your easements and right-of-ways, and this project had an enormous amount of pipelines and utility easements, which became a nightmare. So Carlson also makes it very easy to calculate points that you can export and take with you out with your GPS or whatever you're using, take it out in the field and help you make your life a lot easier when locating these corners. So in addition, when you're field prepping, I like to provide some kind of scope of work. You're going to need to provide control, whether it's site control, NGS, monuments, something that they can calibrate to, along with contact information. I also provide aerial maps with those calcs and working sketches, Google Earth images, anything that's going to make the life in the field easier. Communication is key to success, and keeping communication with clients, landowners, your field crew, whatever you have to do, you're going to need to do as a project manager to make sure everything runs smoothly. So now that you're out in the field, your initial field work is going to be mostly locating corners, monuments, pipelines. Especially in the boundary, you're going to do a lot of digging. So here are some original monuments that were called for. These are iron pipes, busting some asphalt to reveal some iron rods that have been set for corners, some more digging, some more iron rods. Here's some pictures of the yard that need to get surveyed, because in Alta, all existing structures and easements and pipelines need to get located. And pipelines, oh, well, they're pipelines everywhere. Here's a drill hole that we found for a property corner. Once you get all that field data, you'll bring it into the office, process it, adjust it if it needs to be adjusted, and then you'll work closely with an RPLS or an SIT, and you'll do the boundary resolution, and that'll basically lead you in CAD to draw a deliverable. In this case, it was a plat. Here's the PDF version, signed and sealed by the RPLS, and that'll get sent to the client. So that was kind of start to finish, the workflow process. Another thing we commonly do, since we do oil and gas work, and those lease surveys often deal with the original surveys, we have to do research at the GLO. So on the left, you'll see these old documents, the old field notes. This one surveyed in 1878, and the concrete monuments on the right were set in the early 1930s by a resurvey, and it's just amazing to be able to follow in the footsteps of the original surveyor, and like a needle in a haystack, cutting through brush and cactus in the middle of nowhere, finding those original monuments. Shifting gears and going more towards technology and the future, Northern White Sands, one of the clients, needed some large sand pile volumes surveyed, and so we utilized a 3D scanner to complete this project. So here are some pictures, and to kind of give you some idea of the scale and how big these piles were. The piles span roughly probably 3 football fields in length. And in order to make the YouTube limitations, I'm going to stop right here.